To be live. All right. Hello to those folks watching on YouTube. This is our Swift Concurrency group learning session where we try to better understand the world of Swift Concurrency and the new Swift Concurrency model. This week we're hoping to try and better understand how to parallelize tasks, if possible, by trying to parallelize rendering map tiles in the CubiomesKit project. In the event that you're just watching this on YouTube, we do host these sessions on our Discord server in the Swift Dev Chat server. You can find the links for those in the description. I encourage you to come join us in one of our group learning sessions live in Discord. I don't know why I'm pointing at the camera like as if my camera was on, but we're going with it. And full disclosure for those that are currently in the Discord, this event is being live streamed / recorded. If you do not consent to being recorded, I suggest that you leave the call now and probably just watch through YouTube. Consent matters. All right. So I guess let's get started then. Yeah, so I think the main thing we're going to need to look at is this render call in the renderer, because that's where we're actually going to be doing things. For reference, I will pull up the GitHub issue I filed for this, because CubiomesKit is a free and open source library where you can generate and inspect Minecraft or worlds for Minecraft Java Edition, such as searching for biomes and generating map tiles. So the last concurrency session we had, we looked into making the world rendering an actor, so that way we're pushing things onto that actor and not polluting it inside of the main actor, which did significantly help rendering performance by delaying some things. And now let's see if we can try to do some parallelization inside of Minecraft World Renderer, which is the actual class / actor that's responsible for generating the tiles in the first place, and seeing if there's stuff that we can do inside of there to make it faster. Faster! Yeah. So, I believe the biggest thing that takes forever is likely to be this biomes to image C call down at the bottom. Because I think the generating biomes part is actually pretty solid, because I noticed that whenever I was playing around with the pixels per cell parameter, which determines how many pixels in the image represent one Minecraft tile, or like one Minecraft block. If I were to increase that, that made it substantially worse in terms of performance, and it would take forever to load. So I don't think it's the actual biome ID stuff. I think it's actually somewhere in here where it's taking the most time, because it has to generate all the pixels.
We just had somebody new join us, and we want to let you know that this is being recorded. So if you don't want your voice recorded, keep your microphone muted. If you don't mind being recorded, then welcome and glad to have you here. Okay. Anyway, carry on, Marcus.
So, yeah, I think this is where we should probably start investigating. I don't know if we want to like validate that by doing some profiling or something, but I have a funny feeling
Normally
this is where we need to look specifically.
So do you want to refactor that into a separate function that can be called on its own?
Yeah, I think we can try doing that. We just need to make sure that we're passing in the right parameters for this.
Well, extract to method, if you use the automated refactoring, it should grab you the parameters needed. if it works.
Refactor.
No,
No.
the extract method is there. Maybe try selecting whole lines instead of like being, because you were partway into the line there, so that's not a whole line. Like go right from the beginning of the line. Yeah, because Xcode is finicky. Try that. No, it's still not doing it. Okay, so we don't get extract method for free.
Yeah. Let me check real quick. Yeah, we're still running 16.4.
Yeah.
No, okay. We're just going to have to be a little...
Copy and paste, and then let the compiler tell us, hey, we don't have this.
I think we could just make this flunk, because that one's already public. Do that, and then I think here we will need to return the RGB data. Okay. So our return type then needs to be of unsigned C characters.
Ooh, raw value types.
Yeah, well, the biomes to image call is actually something from the Cubiomes C library, which is where a lot of this stuff is coming from in the first place, so that doesn't surprise me. So
you need your range and dimension, biomelds.
Yeah.
Pixels per cell.
Range. That should be a Cubiomes range, not a Swift range.
Okay, yeah.
Pixels per cell, I think it is an int 32. If options contains, well, options should be provided by.
Yeah.
Oh, it's streaming about dimension. My
dimension.
bad. Yeah. So that's the Minecraft world dimension.
And your range, its underscore range is the name used in there. So
we can just plonk that. And then plonk
sure, it's used,
that. I only did lowercase because technically I guess somewhere in here I initially wrote it as like regular range, but I think I refactored it because I changed it to like Minecraft world rect, my own type. Yeah, in rect, so that's where I changed it.
You wrecked it.
Ha 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 ha.
Sorry. Actually, I'm not sorry. I enjoy making bad puns.
What is type biome IDs?
Ooh.
Biome IDs.
The D is lowercase in where it was being used, wasn't it? Oh, no, that was just how Apple was presenting it in the warning. Yeah.
Well, no, that's how I wrote it in here. But I'm changing it now to match. Okay, cannot find biome IDs, and that's fine. Okay, cool. So
now we have that function.
Let's take you then, and then let's say let RGB data equal range, pixels per cell, dimension, biome IDs. Oh,
some of those are you still used in there? So take them out and pass them in.
Yeah, that's what we're gonna do. What? We can always refactor this later to clean up the interface. I'm just doing this right now so that way we can do things. What type is image width? Should be just int 32, right? Yep. Int 32. Image height. Int 32. Yes, I know. While we're at it, I'm going to do this so it's easier for me.
Control M.
Control M. Oh!
You
Keyboard
didn't know that one?
shortcut.
Oh, that is such a beautiful
I know
shortcut.
Control I, but I don't know Control
Yeah.
M, apparently.
Well, now you know Control M.
But also, I probably would have just as lazily did this.
Sure. Yeah.
Which is Shift Control I.
Yeah.
Okay. Before we do anything, I want to see if we can get the tests to run just to validate. There are no bundles
Yeah.
to test.
Are you in the right scheme? Or?
I was loaded in the demo app, which Xcode does not like it when I do that because weird things. Okay, so let's run the tests because this is unit tested. Because I want to make sure that that simple refactor did not cause the whole thing to explode.
Right. Which is why we have regression testing. Okay, self-destruct sequence initiated.
That's
failed to locate resource name default.csv. What's that about?
Default.csv. Oh, I think that's for localizations.
Okay.
That I don't think that's actually related to CubeOmes because colors are defined in a text file, not a CSV file.
Yeah.
How peculiar. Can we... Oh, well, I guess we're in the backtrace view. No, okay, so something is going on here that it didn't like.
Is that bracketed C unsigned car return type? Is that definitely... Oh, yeah, because it was already in there. Yeah. What I would suggest doing is unrolling what's been done here and instead take the tiniest piece, like line 136 to 145. Okay. Maybe take that and make that, pull that out as a separate function and see if that breaks anything. Oh, and did you run the tests before making the change? Because maybe there was some other, the rule of always run the tests from the clean state before you start working. So you run the tests now.
It should pass because we're not compiling under Xcode 26.
Okay. Yeah. So that's clean. So lines 115 to 124, I would see if you can extract those as a function.
Okay. Yeah. Let's do that. And we know it's going to return that. Okay. Image width, int32, image height, int32. Biome colors is of what type? It is that.
Oh. Wow.
We can type alias it later.
Yep.
Oh, you didn't like that.
Oh, because it has to be an in-out parameter.
There we go. Biome IDs, I believe we had covered that before. And then we need range.
You could control M at this point and that'll clean up
there
your...
Yeah. Range is a CubeOmes range. Pixels per cell. int 32. And then at the end...
uint 32 by the looks of it.
We're
that's what's
converting
being
it
converted
inside.
to.
Yeah, we're converting it inside.
Yeah, okay.
And then... Look. Nah, I think we could just do let. We'll see. Okay. Run them again. Huh.
Okay.
So you liked that, but you didn't like it when we included that. Interesting.
Now I'm wondering, is what is currently the applesauce function, is that enough to say, hey, call this as a parallelized task? Or are the lines 108 to 113, is there a lot of work being done?
That is a good question. Huh.
Because maybe we don't need to separate out 108
Yeah.
113. Maybe just this applesauce. And if we find that isn't enough, then maybe we go back and we bring in these other lines.
Yeah, that is a good point, because I guess you don't really necessarily need to parallelize the color initialization.
Right.
This is a good start. Let's see if we can clean up this call site a little bit, though, before we commit this. Well, I don't want to necessarily do a implicit... Okay, well, let's do a few things. Can we rename this parameter? We can.
Yeah, the renaming is the one refactor that seems to work pretty well in Xcode. Everything else is hit and miss, mostly miss.
Yeah. Thankfully, I bound this to F2, so... Because that's how it works in like VS Code and a couple of other editors.
Oh, okay.
I liked that general approach. I forgot what the original key binding was, if there was a key binding.
I don't think there's a key binding on that, if I recall correctly. I might be misremembering. Yeah, there's no key binding on refactor rename.
Yeah. Yeah. Let's.
But yeah, that point of if you find yourself using a function repeatedly, either learn the keybind or add a keybind and learn it, because it's just, yeah. Sometimes when I'm mentoring folks and they're doing things, I'm like, there's a faster way to do that. You don't have to do the same slow manual thing every time.
It's a very interesting thing, going on a side tangent as I'm writing this out, because there were some folks, I'm not sure if you're familiar with the name Martin Curie. He goes by Tanterpool on YouTube. He designs products, or is the head of design for products such as MuseScore and Audacity.
Oh wow! Okay.
So he's the lead of that, and if you're wondering why it looks modern and more better design, it's probably because he had a hand in it. Once upon a time, he worked with Microsoft to create the Paint 3D application, and initially he had keyboard shortcuts for undo and redo and stuff like that, but no buttons on the screen to do so. Everybody thought it was okay at first, and then they initially handed it to testers, focus testing reasons, to see how well it worked.
Yep. Try with actual users.
A lot of people were confused and didn't know how to undo.
Right. Yep.
So they added the undo and redo buttons back in, and they learned over time as they collected data and stuff that the undo button was the single most used button in the entire app.
Yeah, and this is, there's a story in that in terms of, here's a key thing to understand. you always have to test with actual users and pay attention to what happens in those tests. Get the actual test data, or you're just making wild guesses. It'd be like if you were, trying to develop new pharmaceuticals, and you were guessing how different chemicals would react with each other, but you don't actually try them. Like, you don't have your people actually trying your new vaccine or your new pill or whatever. You just sort of say, well, if we put these chemicals together, it should do this, and that'll work just fine. No, you actually have to test to know if it does work. This is something that a lot of people in our industry tend to not really appreciate.
That's curious in here.
Stuff out there. Sorry, say that again?
Yeah, just curious in here because looking at the method that you have where you're passing in the biome IDs, but then you're also deallocating them in that method, which doesn't seem like a good idea.
Yeah, the deallocation
you're right. We can
move
that outside.
Yeah. Okay.
Yeah.
I'll just run it again just to make sure that's a sound change, but yeah, that was just a blind copy pasta without any thinking.
Although, if that generate image data function is going to be happening inside of a concurrent multi-threaded parallelized context, if it is the last user of those biome IDs, because biome IDs isn't used anywhere in the render function after that line 126. Yeah. So really, it does make sense to put it in with the generate image data. But what we would want is ideally, and we're not going to do this today, but we would want to use that new thing, which I think it's in Swift 6.2, where you basically have like a destructive copy or whatever, where you pass a variable to some other function, and in the process of passing, your copy of that variable goes away, so that you no longer have it after you've called that function. The function that you called has it, but you don't have it anymore. And I forget the exact terminology for that, but that's what you would want here, because that's effectively what we're doing. Biome IDs, after line 125 here, has no value to the render function. I would say definitely move it back into the generate, because we'll be calling, if we're calling generate on 118, and we're calling it asynchronously, we're sending it off as a concurrent task, then we might be deallocating on 126 before the generate function is finished working.
Yeah, we want to make sure that if that does happen, like if this is the last point, that like we absolutely should make sure that like it cleans up after itself, so that way it doesn't get cleaned up by something else while it's trying to do things.
Yeah. I mean, what I would note here is that in calling generate image data, the biome IDs parameter, the caller of generate image data is giving up ownership of that of the biome IDs. That ownership is being passed to generate image data, and the caller, the render function, should not touch biome IDs again after it has passed it to generate image data. I would document that very clearly in like the doc.c comment for generate image data, so on, because it just that is a dangerous thing we're dealing with. I mean, it's the correct thing to do given the code that was in place before, but it is nonetheless dangerous because we're passing ownership. So we want to very clearly call out that ownership has been passed, and it is not okay to use biome IDs in the caller after it calls generate image data. This is one of those things with the sharp edges of concurrency. You have to be very clear on who owns what. Yeah, I would explicitly note that the caller must not do anything with that biome's IDs parameter after calling generate image data. Basically, the calling function has to say, you're dead to me, biome's IDs.
Okay, cool.
So now the question becomes that RGB data that's being returned. Right now, we're using a sequential functioning of this. So as an interim step, we could make generate image data async and call an await on it. So it's still sequential.
Yeah.
But now we're a step towards that asynchronous.
Yeah.
But that may in turn end up with propagating the need for asynchronous up the stack of calls unless you wrap it in a task.
Yeah. Yeah. That is true. Let's commit what we have real quick. Just to make sure we're not losing anything. By the way, Keith, if you'd like to be acknowledged in the contribution, please send me your name and email as it corresponds to you in Git or GitHub or whatever, so I can add you to the co-authored by.
And I'll just say one of the principles we operate on the collaborative coding that we do on this server is that even just being another pair of eyes on the code is a valuable contribution, because you may see something that somebody missed, like when Joe called out the thing about what we were dealing with that biome IDs parameter, or it's further reinforcement that if 5 pairs of eyes instead of 2 pairs of eyes look at some code and see, okay, yeah, that looks okay, then we have greater assurance that the code is good. It's a continuous code review process is what pair programming or ensemble coding provides. And so it is a valuable contribution. Even if you end up not directly adding anything to the code, you're adding to the process of getting to good code by being another pair of eyes.
Mostly just excited about seeing how much faster it is.
I know, me too. Because if you've seen the way that it is currently in Aladade 1.0 on the App Store, it's a little bit slow.
Yeah, because you're going through and sequentially rendering each file graphic and then passing them to MapKit, right?
Yep.
Yeah.
I hadn't even leveraged the new stuff that we did the last time because it doesn't compile under Xcode 26 yet. Which is unfortunate. So yeah. I need to fix that. But right now we're running under 16.4 for the purposes of this learning session. So that's why we're not getting any of those issues right now. So I'm guessing since you haven't sent it, you don't want to be included. That's fine. I am not going to be a stickler on that. So I forgot that the fold command strips emojis because I guess it was built in a time where it didn't recognize UTF-8.
That's sad.
Because
I'm
that's
actually
that's
getting-
internally what this services format git commit message is. It's a Siri shortcut that I created that pipes the output to fold to have it automatically fold, since, you know, Xcode is one of those few editors that does not show a freaking gutter at 70 or 72 columns or whatever, and you can't set it in the staging window.
Yeah. Xcode's Git integration interface leaves a little bit to be desired, to be sure.
So I'm not sure why this is being... Why is that being staged? I don't know.
That's a leftover from our previous...
Just lost the commit because I...
Oh, no, do Option Command C.
Option Command C?
Yeah.
Oh my goodness, that is...
Option Command C takes you to your current commit in progress. Learning all the shortcuts today.
Huh. Spooky. I guess I'll just stage all. Whatever. Okay. Moving on.
As previously discussed.
As per our previous discussion. Yeah, so the next thing I guess would be for us to slap an async on this. Right?
Can we look at the stuff that comes after the generate image data call? So those lines 127 and 128.
Yes.
What is that doing?
So it is creating the PPM data. So the image format itself is stored as the portable pixmap format, which, if you're not familiar with this format, it's a very crude way of saying this is what each pixel is.
Sure. Okay. But in terms of what it is functionally doing, that's just converting the pixels that we just generated into that PPM format. Is that what those two lines are doing?
Yes, it's taking the array of pixels and it's converting it into this file format.
Okay. So, and then whoever called the render function is getting that PPM data back.
Yes.
In a data object. Okay.
Yeah.
Or data struct or whatever. Okay. All right. Sorry, just trying to be clear on what's going on there.
Yeah.
So generate image data asynchronous.
Sorry, that was bothering me. I might have some performance
Yes.
Because unfortunately, when I copied over the CubiomesKit thing, I think I forgot to copy over the Swiftlet file that enforced the rule. Oh well. Yeah, so all that this is doing is just putting it into the right format and then setting it in a general data object that it can understand.
Totally fair. Yeah.
Doesn't do anything with the biome IDs, so we're clear on that.
Yeah, if we scroll up to the top of render, biome IDs is created on line 105.
Yes.
So it's not accessed anywhere outside of that render function. So passing it into generate image data and giving up on it after that is totally fine. There's no data race risks or anything like that. It's because render owns biome IDs. Render calls generate image data, passing in biome IDs, and then render doesn't do anything with biome IDs. It gives it up after that. So that, there's zero data race issues there.
Currently.
Yeah. So there's no safety issues on that.
Yeah.
Okay.
So I guess the first thing we can try is just to see if we can just mark this as async.
And then at the call site, we'll have to await.
In a function that does not support. So we would need to make this async.
Or because then anything that calls render is going to have to be async. So instead of making render async, although we may want to make render async, but for now, just wrap this in a task, including, no, we can't, because we need that return data.
Yeah, we need
so
the
we can't
return
wrap
data.
it in a task. So we have to make render async, and then whoever's calling render will need to either wrap it in a task or itself become async. And if you go and right-click on render, show callers, second item.
Thank you. Thank you, Xcode.
So
Very helpful.
Maybe rebuild first. See what command
Build
line gives
succeeded?
us errors.
No. Oh, wait, maybe it's because it's under a different actor. Huh.
Oh, it was already being called from the call site across actors, so it was already being called async.
All right.
Oh, well, then we're laughing.
We're laughing.
Let's run it and see what it does.
Now, I'm just going to prepare this in advance.
Are you ready for the pain?
Because the last time I tried to make this function call async, it threw a hissy fit around here because it was like arithmetic overflow. So let's see if that happens again when we run the tests.
Yeah.
Negative value is not representable. That's interesting. What is the value of these? Range? What is range.sx? It's a negative value. That's interesting. Because we're rendering at negative 99, negative 135. Huh.
Why does it need to be converted to uint32s there instead of being just signed integers?
Because that is what the function requires.
Yeah.
And one of the hard rules that I have right now, because I don't want to have to maintain a fork, we cannot change cubiomes.
Yeah, that is 100% fair.
Yeah.
Well, you were right in saying here comes the pain.
Yep. But it's only when I make this async that's when it screams about it. I'm not even sure.
There was the range.
Range is a cubiomes struct, not a Swift range. Where it's
retrieving it when it's getting.
You're cutting out. Or maybe I'm cutting out. I don't know.
Go back.
No, Joe is cutting out.
Okay.
Can you try again, Joe?
I mean, let me switch my AirPod. I was going to say, where can you go to the code where you're getting the range?
Being defined inside of here. Range is effectively more like a CG rect than a range as we Swifties know it. It was the C developer that wrote cubiomes probably did not think that a Swift developer would be writing this and would get confused between the two range types. So, you know.
Yeah, can you put an explicit
there was any change
namespace? Sorry, Joe, you were cutting out again.
Okay, I'll just let you talk. I'll go on mute again.
If you're having microphone difficulties, maybe use the text chat and you can go from there.
Because I do have that open on the other monitor here. It just won't display on here for reasons. But yeah. I want to see on which test it causes this crash and burn.
Yes, that would be useful.
So let's see if this even happens on these tests to begin with. Okay.
Yep.
Okay, it does. It does. Okay. So we're able to track that down. That's good to know. So it's not because it's being passed a funny thing in another test. No, it's happening directly in the rendering. So at least we're able to confirm that.
So why is it ending up with those negative values?
That is a good question.
Can you figure out at what point
We could
those numbers are being made negative?
Actually, you know what? Let's rerun this test, but then step through it. Okay, now we do have our origins there. So the point that we're grabbing is 116, negative 31. That's on the X and Z coordinates, respectively.
Okay. So is that negative 31 a problem?
It shouldn't be, because this SX and SZ is a scale. Like, it's a length and a width. It's not. It's not
okay.
It's
so
not
that
a position.
Should always be positive.
Yeah.
So that size that we're about to do, the line that we're paused on, 88, that is what's going to do. So if we could look at self map scale raw value.
Yeah, so rect map scale raw value, which just got stored under size, is 4. Positive.
Okay.
I'm not sure if you're able to see the little
yeah,
window
I can, because I'm on a big screen, but yeah. Thanks for zooming, because most folks probably wouldn't be able to see that.
I don't know how that displays in the recording, but
yeah, I don't know about the recording, but on screen it looks good.
Yeah.
We can see the zoom.
Yeah, my OBS window looks like it's showing it as just the full thing and no zooming. But Discord-wise, you could see here that.
Yeah. Fix it in post-production.
We'll fix it in post.
Yeah.
I don't like working with the YouTube editor, though. That's the problem.
Yeah.
Now, it could be possible maybe something in here is causing it to go negative, because what this is about to do is, if we're telling it, okay, the origin is not the top left corner, but it's actually the center of the square. So it may be possible that there's some weird shifting thing that's going to cause it to do some weird things.
But this, all that should be happening between lines 90 and 93 is range X and range Z being set.
Yeah. So...
And I probably just gave away that I'm Canadian. Z. Because I realize you all don't say it that way.
I mean, I'm an American, and earlier in this call, I said X and Z coordinates.
Oh, nice. Positive influence.
So, I mean...
Yeah. Okay, so...
Yep, so it got pushed back to 99 and 135 on the origin.
Okay, but that's the stuff that goes into the X and Z. But the rect dot size, can we take a look at that? Can you expand the rect? Just in the on the left. Yeah.
So this is my custom type Minecraft World Rect. This is not the CubeIoms one. We're about to generate
Yeah,
the
but we
CubeIons one.
but we will be referencing rec.size.length and rec.size.width, and both of those are 256, so they're both positive.
Yeah. So our origin is 116x negative 31z. Our size is 256 by 200.
Because you were saying it was SX and SZ that were the problem
Yes.
ones, right?
Yeah.
So we care about what's being assigned to them, and these two values, the length and width that are both 256, are the values currently that would be assigned to them. I am wondering if, because this is asynchronous, something else is holding on to references, and instead of passing values directly here, we should maybe first copy the values and then pass them along, so that because if these are pointing to something that somebody else is still pointing to and goes and changes later, that would be why again, data race issues.
Yeah.
That would be why the asynchronous thing would be changing it.
Yeah, I think that's probably what's happening.
Yeah, so what you may need to do is have, like at the call site, maybe be setting up so that it's passing by value instead of passing by reference, which may mean changing the render, the parameters that render takes. Because are any of the parameters that render takes, are they passed by reference instead of passed by value? Because that would be the issue.
Only one that I think is
can
passed
we
by...
scroll up to look?
Well, inside a render, we're not passing anything by reference at the public call site.
No. It is Minecraft world rect a pointer or a value?
That is a struct.
Minecraft. Okay, so it's a sentable struct. Okay, so that should be passing by reference and not by value, or by value, not by reference.
Yeah, all the reference types are inside of the function, not outside.
Yeah.
Well, I guess Minecraft World Renderer is also a reference type, but we're not passing any reference types into the render function. Let's put it that way.
Okay, so what are we passing into the generate function?
The generator creates the...
Oh, no, not the generator function. The new function that you created. If we scroll down, that new one the generate image.
I'm just going to stop here because we were still in the debugging mode.
Okay.
Because we were still debugging.
That generate image data.
Yeah. The only thing I think that we're passing in by reference is probably this biome colors thing and maybe the biome IDs.
Oh, yeah, biome IDs is passed by reference.
CubeIons range is a C struct that's defined.
But a C struct, because it's in C, it'll be using a pointer instead of a value, because C, when you're passing stuff around, you're passing pointers. So
true.
So maybe instead of the raw C data there, we need to convert that to Swift values. That range from CubeIons range, change, either extract the bits we need out of it, because we need the SX and the SZ.
Yeah.
So maybe extract those and pass those in directly instead of passing in the CubeIons range.
Yeah.
Yeah, that should fix it.
Scale Z, uint 32. If I can type. And then here, we don't even need the conversion, because we can just do it at the call site.
Yeah.
Meow. Probably could have done that a little faster with Vim motions, but eh. Okay, scale X is 32, not 42.
42.
We've unlocked everything.
Oops, your eye is
Yeah,
on the case.
I keep doing that. I don't know why. Okay.
Okay, now let's run the tests.
Yeah. Run it again.
No.
I mean, it's a good step in the right direction because it's now hoisted.
Oh, and it's just SZ. Oh, is SZ still that minus 32?
Let's take a look and see
Whatever,
what it
minus
got.
31?
Range X. Ooh, hold up. If I can remember to zoom correctly. Oh. Those are some big boy numbers. Because these are not
Yeah, like an overflow.
ints yet. These are still in 32s.
Yeah, so the well, and it's supposed to be 256. If it was, yeah, like look, there your size.
Yeah,
256.
not necessarily because in the
you do
range
some other math that
here,
shuffles
yeah.
it.
Well, no, we're passing it in directly. I think when it does stuff with the range, I think it changes a few. No. Okay, you know what? I think the problem is I ran Command U on everything, so it might be trying to actually render something else.
Oh, okay.
Okay, there we go. So we've recreated it.
Yeah.
Still 256 on both fronts. Somehow range X and range Z have been converted to... They're really big. I don't know why that is.
Yeah.
Oh, well... Hold up. I think I may know what's going on. Let me check something. Minecraft World Renderer. Okay. Before we get to this point, I'm going to put a breakpoint.
Yeah, see what's coming in.
I think I know what's going on. So let's take a look down here.
At the range. Oh, expand range. The underscore range.
Underscore range.
Yeah, those are 256.
Yeah, so that's not the issue there. Options, raw value. Okay, well, that's not helpful. Thanks.
Okay, in the LLDB line in the console, just PO uint32 underscore range dot SX, like. Yeah. Huh.
So it's not... Okay, that's interesting. Okay, so it's not what I thought it was. What I was thinking was the default option, or one of the default options when you create a renderer is, unless you specify otherwise, it'll assume that the point that you're drawing is the center of the square. So I thought that maybe there was some weird shifting going
that it
around.
might be shifting it.
But I forgot that...
Yeah.
Oh, wait a minute. Range X and range Z are not... Those are the coordinates. That's the origin.
Oh, right. Right. So what happens if we step into the function now?
Give me a second.
Yeah.
I'm going to put the breakpoint here instead because it seemed to give up even before it hit the breakpoint. So... Okay, so we get our generator, we set our origins. Now, if it contains the center positions, which in this case it does, it does these calculations to offset it per the pixel.
Yeah.
Origin X and Origin Z right now are now -99 and -135.
And what is the rect dot size?
Rect size is still 256 by 256.
Okay, so those look good.
And now we have our Minecraft range, where if we look down here, it looks like those values match. Scale of 4, that's the small size.
Yeah.
X and Z look right. The scales look right. Y looks right on both.
Yeah. So what do we get? Wow, this stuff was where issues were happening.
Yeah. So biome IDs generates a thing, which we're not going to be able to see there, but
Right. Yeah, that's a C pointer.
Oh, did I hit step over or did I hit continue?
I do not know.
Just quit before I
Build
could even.
Succeeded. Okay. Huh.
Let's try that again. No, it just straight up gave up.
Test failed.
Fatal error.
Fatal error, negative value.
Is not representable.
So that's happening earlier than we thought. Because we didn't
So
even
it's
hit
somewhere
down.
in here that it didn't like. Interesting.
Okay, what type is pixels per cell and what type is the .sx?
So this is an int32. This is an int32.
And 30. So those should be fine.
Should be the same here.
Yeah.
I think this was the same thing that I was running into last time, actually. This exact spot was where I was throwing a hissy fit. So let's run it again. Though, when I ran it before, this is probably because of some weird things with Xcode 16.3 versus Xcode 16.4. It just said arithmetic overflow. Whereas here, now we're actually getting like, oh, there's no negative representation.
Yeah, so let's go down to just before those questionable lines.
Let me see if I can just fast forward to the next breakpoint. Okay, here we go.
Yeah. Okay, so range.sx 256 pixels per cell, that's 4. So that's fine. So step over this line. And
it gives up.
That's bizarre.
Negative value is not representable. I mean, this should always be positive regardless.
Yeah.
I mean, it should always be positive, right?
Yeah.
So maybe there's some weird shenanigan going on there. Also, I just ran all the tests instead of the one.
Right.
Okay. Let's move forward.
No. Self-destruct. So it's happening in the multiplication.
Yeah.
So the result of what is it? No, because 256 times 4 is definitely less than 65,536, which would be an int32 limit.
It's 1024.
Yeah. So there's no way that's hitting that one. That is bizarre. Like.
Yeah.
Okay. Where is pixels per cell coming from, and where is underscore range coming from?
Pixels per cell is defined as a parameter.
Okay, so that's just a raw, like int32 value. Okay, that's fine.
And these come from this struct.
Yeah. So what would happen if instead of, like on line 108, instead of underscore range.sx, you pass in rect.size.length. Let's give that a try. Don't do the other one yet. Well, you can, but just need to try one. See if that makes a difference. No, that didn't fix it.
I think maybe it's crashing when it's trying to get to here. So maybe, what if we move the breakpoint? Maybe. Let's see.
Sure. Have you tried turning it off and on again?
Okay. So it did pass.
Okay, it made it there.
So it's got to be something here that it doesn't like. So let's check real quick what image width is. It should be 1024, but okay, yeah, 1024.
Yeah.
So it's happy about that. Okay.
And range.sz is 256. Pixels per cell should be 4. Yeah, it's 4. Yeah, we can see on the left what their current values are. Oh yeah, there's a good idea. Do it right in context. So that works. What?
Though I would like to try your suggestion where we changed it
to... yes. Rather than accessing through the underscore rect.
Yeah. Because...
Or underscore range, rather.
Yeah, this is only realistically used for the generation of the biomes itself, really, when we think about it. So let's see how that handles it. Ooh, that's interesting. Okay. Why did it do that?
Negative value is not representable. Okay, so hang on just a second here. So in integers.swift, on its line 3048. Yeah.
Can we?
Oh, this is frustrating because this is holding us back from moving forward on the async stuff.
This was exactly the issue that I was running into when trying to make the whole thing asynchronous in the first place before we did stuff with actors. I think I even had noted it in one of the GitHub issues too, if I remember correctly. We were to go...
Ooh, blinded.
Hey, not my fault that Wikipedia decided.
Oh!
Automatic, there we go. Issues. Closed. Make world rendering concurrent. And I think, when attempting to write an asynchronous version of the render method in the world renderer, the test would crash from an arithmetic overflow. However, this only occurs in the async version. I suspect there might be a race condition.
Except we've now established that the values are correct, so there's something weird going on there. Now, maybe hide the console, Command-Shift-Y. So pixels per cell, we're certain is a value because it's passed in as just a straight up in 32. What is rect? Where's the definition of rect?
That is a parameter you provide, or an argument you provide.
Yeah, and that's a native Swift thing. It's not bridged to C on. And rect.size, what is? I'm assuming that's just like a CG size or something.
No, it's actually something I define here because CG size does not support 3 dimensions.
Okay, so that's another struct. That again is just using all int 32s.
Yep.
Nothing special or weird there.
Scale is just an enum, which is also int 32s.
in 32. Yeah. Huh. This is a mystery for the ages.
I mean, one thing we could try, because we know what the hard-coded values are.
Yeah.
Like, if it fails on this, my God, we have a problem.
Yes. Yeah, that is actually an excellent way to test this.
So let's run this again.
We hit the breakpoint, step over the breakpoint, and we get the crash. Let's see here.
Actually, wait a minute.
Why is it pointing down below?
That's interesting. LDB error, no location, value may have been optimized out.
Oh. Okay.
Is it that these values are being generated and thrown out?
Well, the compiler is optimizing it. And
that's spooky.
Yeah, because you're doing an arithmetic against two constant values. It's like, okay, well, we don't need to compute that every time you run this program. We can just store those raw values, which would be 1024. So instead of having image width and image height, you would have, just 1000. That's what the compiler is doing. Wow.
We could see if this just works.
So yeah. Boom. Ooh. Negative. No. It does not like...
because we're still using the old Minecraft range here. We know that this should be 256, so...
Or 1024? Or no, 256, right, because this isn't the width and height, it's the... Yeah, it's the scale.
I know,
okay.
Confusing.
Yeah.
Okay. Run it again. It doesn't like pixels per cell either? Okay.
Where's pixels? That was a...
This is a parameter we provide here.
And int 32. So it's... Let's make pixels per cell passed in as uint32. So on line 139, let's just say it has to be uint32, so we don't have to do the conversion in this function. Now you'll have to wrap,
Okay, let's see what happens.
We'll slowly get to the point where you've got no parameters. Okay, so it doesn't like
pixels per cell. Interesting. Okay, well, what happens if we change this to 4? Just straight up raw value.
Yeah.
Okay.
Okay.
So it's something wrong with this, with a conversion from int32.
Of int32. Yeah. Painful. Anyway, this does mean that we can start to move forward a bit, and at least figure out the parallelization side of it, and then come back and try to figure out why this stuff leads to so much suffering.
Curious. I want to see what happens when we do that. The test succeeded there, even though I... Okay. Okay, what if I change this to pixels per cell? Instead of doing it raw value. It succeeds. Why is that?
That's because we're being told that we need to quit programming and take up farming.
Clearly.
and I'm getting flashbacks to working on multi-threaded code.
This is Oh, Grant, I cannot hear you.
Oh, sorry. Um, my internet briefly phased out, and anyway, I was just saying this is giving me flashbacks to working on multi-threading code in the 90s, because this is what it was like continuously.
Yeah. That is so strange. Pixels per cell is such a small value, though.
Yeah,
Why would it...
there's no reason it shouldn't be able to convert.
Why is that such a problem?
Well, can we proceed with the asynchronous stuff from here
Yeah.
and then come back after and try and figure out why these numerics are all messed?
Yeah.
Exactly. This is where I throw in the angry orange swearing emoji.
I did the Swift, I don't know how you pronounce it, REPL thing, and it doesn't let me convert an N32 to a UN32 there either.
Oh, wow. Huh. That's bizarre. There's probably some weird special Swiftism then for it.
Yeah. Well, okay. Well, we got to this point, so...
Yeah.
I think if we run the full test suite now, it should theoretically pass, because I don't think I specify different pixels per cell on anything else. Yeah, no. It's all using the same numbers. I think, in fact, I don't even specify that because it's a optional argument.
Hang on a second. So there's a special uint32 initializer. Actually, there are a few of them where the value that you pass in, you give it a parameter name. So truncating if needed, colon, and then the value you're passing in, or big endian colon and the value you're passing in, or truncating bit pattern colon. So anyway, that's what you need to be doing to get around that problem, because just straight out passing an N32 to a uint32 will not be happy. No.
Okay, well now we crash directly into Cubiomes.
So it's a little bit better, maybe. I think. Who knows? But anyway.
But
so
this is actually this is actually directly into initializing colors. This is not a pixels per cell thing, I think. Huh.
Okay. Anyway, for the future investigation, that would be the...
Paste those initializers, or one of them that you were talking about, into the chat.
Okay.
Let cat uint32 is dog.
Yeah, that's a straight up initializer, but in terms of one that deals with these type conversions that we're dealing with here, it needs the parameterized version where it's got like an actual parameter label saying, okay, what do you do with this? That's not just a plain simple conversion. Anyway, we can come back to that.
Yeah.
So now we've got this asynchronous.
Yeah.
Are you able to run your whole test suite?
Do this again.
Which might fail because we've changed some of these numbers around to be static numbers. Oh, no.
No, that's what I was saying. Most of the time, because this is a optional or default argument here. I keep saying optional, but that means something else. Because there's a default argument here, we technically don't even need to provide this. And I think in any case, like if we were to say jump into the mapkit interrupt where we actually, those are the tests. If we were to jump into the mapkit,
so you're not going against the defaults anywhere.
Yeah. Currently. So it would be. Okay, well here we're passing scale 1, but because it's hard-coded to 4 anyway, it's not a big deal.
Okay. Yeah. So anyway, so happiness, the tests are passing. We've got the function asynchronous. Now we need to say, okay, how do we set it up so that we can have a bunch of these tiles being rendered at the same time?
At the same time, yeah.
Yeah. So I think, like we were talking about before this, if we had a task group, and within that task group, we were making multiple calls to render based on whatever needs to call render.
Yeah, that's the tricky part here, because where that happens, most notably in this project, is here in the tile overlay.
Yeah, like I would assume there's a loop somewhere that loops through, and
yeah, I think that
for each
might
tile,
be inside of MapKit though, not in our thing.
oh, so MapKit is calling back to you.
Yeah,
Oh,
it's telling me, hey, I want this, give me this.
okay. And there on line 57 is the call to the renderer,
Yep.
the function that we were just looking at. So you don't actually manage the loop.
I do not manage the loop.
MapKit
No.
manages the loop.
In this particular instance, with this MapKit integration, I do not control the loop.
Is there a way then for you to perhaps pre-render the tiles and have a cache of pre-rendered tiles that you feed back through this load tile function? So the load tile function, maybe it hits the cache. If the tile is in the cache, sends that back. Otherwise, spins off a renderer to fill in the cache. But in any case, I don't think we're going to be able to set up parallelization here, because the loop is owned by MapKit and not by your code.
Yeah. Which is a little bit of a problem here.
Yeah. Huh. Oh well. It was worth a shot. That said,
it's not all lost cause, because we did say in the thing, checking to see, where is it? Make world rendering concurrent issues. Right? Part of it is like, can it even be improved with parallelization to begin with?
And we've just somewhat answered, like, although the parallelization then, so MapKit, because when I've seen it rendering in your app, it's rendering multiple tiles at once, and they come in a scattered order. So it is doing parallelization. So the calls to your load tile function are already being called in parallel.
So
yeah.
And I think part of that was because we moved it away from the callback behavior.
Yes.
Into the Swift concurrency version. And I think because on macOS, the MapKit view, I've set it to can draw concurrently, which, again, I don't know why this doesn't exist on iOS, but...
Yeah. So, then I would say the next step would be to run the instrumentation against your code and say, okay, is there, what is stalling things here?
Yeah.
What's the biggest bottleneck? Now, in this generate image data call, if we scroll down to the function where it's doing the work, biomes to image. Could that potentially, within that, is there potential for parallelization there? Because it's doing it's got to go over and render a number of different pixels. So
yeah, here is a
would it be
so
possible? Would it be possible to sort of split that up? After profiling it, to say,
Yeah.
okay, is this actually taking a long time? And if it is, then that would be the place where you'd want to be bringing in parallelization. But that's in raw C code now.
Though it looks like, theoretically, I could maybe potentially not even need to use this and write our own.
Yeah, if you read this code and created, if you Swiftified it, then yeah, then you'd be able to write inside Swift, parallelize that stuff, if the profiling showed that was worth doing.
Yeah.
Yeah, because that's not a very big function.
Yeah, no. Like, let's see what this is actually doing here. So we grab, I don't know what ij is. Oh, okay. That's just grabbing the length and the width of it.
Okay. This is why I like having SwiftLint say no single letter or two-letter names. Everything has to have at least a few letters so you have a chance of it meaning something.
Even in C code, I would still have more qualified names.
Yeah, there's no reason to have short names unless it's something like RGB. Okay, that you can get away with. XYZ as a Cartesian coordinate system. Okay, there you can use. But other than that, it's like, and I make an exception for ID being only 2 letters. Other than those, it's like everything should have actually meaningful names.
Yeah.
Anyway, side rant.
Yeah. No offense to Cubitect, the main developer behind Cubiomes. Yeah, so we're just grabbing in the pixels, grabbing in our colors, as well as the biomes itself. Then we have our length and width, we have the pixels per cell, and then we have this const flip thing to say whether we want to have the image flipped, which here we specify 2, which I think is just no flipping whatsoever.
Okay.
Right, so we create a contains invalid biomes, and then we just loop over each cell. We try to grab the corresponding biome. We set up our colors. If, for some reason, the biome ID is not a valid color,
is out of range,
then we set that flag, and then we do some funny magic. I'm guessing to compute it such that it is in a valid range. It looks like.
Well, that's probably a special color. Oh no, that's a shifted color because it's dependent on.
Yeah.
Dependent on the.
Yeah.
Okay. Anyway, so it's doing some weird math magic to enforce a particular color based on the ID being outside of a set range.
Yeah.
Oh, okay. Yes, because each color RGB is an 8-bit value.
Yeah.
If the ID is not an 8-bit value, if it doesn't fit within 0 to 256, or rather, 0 to 256, whatever, then this is basically shifting it to produce an 8-bit number. Yeah, constraining it to an 8-bit number to force that. Okay, that makes sense.
That makes sense, yeah. Otherwise, just grab the colors.
From a color table based on the ID. Yeah. Okay.
And then after that, we get... Okay, so this is where we start to actually do some things with the image.
So what are
Well,
M
actually,
and
this is
N?
pixels per cell here. So I think this is just scaling it. Int index
But
is...
what are the M and N values?
M is 0, M is less than pix scale. Well, because pix scale here is saying, okay, for one Minecraft block, how many pixels wide and tall is it going to be when we render the
Okay,
image?
so M and N are probably width and height.
Width and height of a Minecraft block relative to a pixel.
Yeah, in pixels. Yeah.
Yeah. So then we loop over those. We check to see if we're flipping it. Otherwise, some index calculation. That part's a little confusing.
Yeah. Well, and the SY minus 1 minus J, where it's all crunched together, is
Yeah.
and then you're getting pixels plus 3 times index is your pix.
So we're grabbing the pixels in the pixel array to set the colors of those pixels. So what this whole loop is doing is, okay, we're finding for one particular Minecraft block, and then since we're saying like 4 pixels, it's taking the first 4 pixels of the thing, then it's dropping down to the next row, next 4 pixels, dropping down, next 4 pixels, dropping down, next 4 pixels, and then it keeps doing that for each tile. So I'm guessing what this is it's changing where the offset starts.
Yeah, the index.
Yeah.
So, yeah.
Okay. And then for those pixels, we're directly setting the RGB values for each.
Yeah.
Wow.
Oh. Okay. So line 560, that's a byte pointer. A car in C is a single byte.
Yes.
8 bits. So pix is a byte pointer, and it's taking the pixels pointer and it's adding 3 times the index to get the offset within the pixels pointer to where we want to be setting color. And it's 3 because it's a 24-bit color, a 3-byte color, RGB.
RGB.
So it's going, okay, how many color blocks within pixels? And that's the index. So the first color block would be at index 0, so you would have no offset from the start of pixels. So that would be your first color block. If you're on the second color block, your offset is 1, so you would skip ahead 3 bytes in the pixels pointer, and then based on that you assign your RGB. Okay, that's just C stuff.
Yeah, it's C stuff. We could probably write it better in a Swiftier format that actually makes sense.
Well, more comprehensible in it.
Yeah, at least more comprehensible.
Yes. So what we're seeing here is you've got this loop that once you've done your setup, you've defined your RGB, and you've got your pix scale, and you've got your chunk of memory for your pixels to be written to. It's then going through and pulling all this, looping through this. So what you could potentially do is chunk the data that's feeding this and say, okay, we're going to do, the first 32 pixels, and we'll send those to one thread. We got another 32 pixels. We'll send those to another thread. So that would be the opportunity for parallelization there that I would see.
Yeah. So it seems like here this would be where we can set up a task group.
Yeah. Sorry,
Pete, you
had a question?
Yeah. How do you guys know how granular to make it? Like how many how many pixels to chunk up for one task or one thread, I guess.
Well, the first thing would be to run instruments over the code and see, first of all, if it's taking some time. If it's happening in microseconds, then you don't bother. But if it's, because we can see a visual delay when running the app, we know that there's some stuff that's not running at like light speed. So figuring out, is this function call, which is our best guess right now, but it's just a guess, where a lot of the work is happening in terms of figuring out what should go into the pixels. So once we identify, if the profiling, if the instrumentation said, okay, yes, this function is doing a lot of work, then we might arbitrarily split it. Start by splitting it in half and say, okay, if it comes in with 128 pixels to do in a tile, then we'll split it into two blocks of 64 and send those out as separate parallel tasks. And then again, go back to instruments and measure, did that get us any speed up? Because if it doesn't get us any speed up, then it's like, okay, well, we won't bother carrying on that road. But if it does get us some speed up, then we say, okay, well, what happens if instead of 2 blocks of 64, we go to 4 blocks of 32? Does that still give us a nice improvement? And it's measuring the time that it takes is the key thing in terms of determining how do you split it. And you can keep going. So maybe we try 16 blocks, maybe we try 32 blocks, but at some point you will hit diminishing returns, and then you'll start to hit negative returns because there's only so many threads that the system can process at a time, and each thread comes with some overhead cost because there's setup and teardown of the thread and re-merging the data at the end. So that's why you have to measure, because just making it multi-threaded isn't a guarantee that you will get any speed benefit, and it might actually make your code slower.
Yeah.
I don't know if that fully answers what you wanted.
Yeah, excellent.
To know about that?
Yeah.
Okay.
Yeah. I think that's what in machine learning we refer to it as a hyperparameter, assuming I'm using that term correctly here in this context.
I'm not familiar with that. Do you want to explain further?
So, making sure that I understand here, is a parameter that can be set in order to define any configurable part. Right? Because this is not something that we would necessarily that it would necessarily be able to figure out on its own. This would be something that we have to put in and tweak to even get the whole process started. But then again, my machine learning terms are a little hazy. I haven't done ML in quite a while. So I could be very well using the wrong term. But like, for example, if I were to pull up one of my own things, Bisma, where is the notebook? Assuming it's still loaded. Yeah, so like, yeah, so for example here, I forgot what exactly these numbers represented because I forgot what dense was in terms of the parameter name, but like, we set parameters here and we keep tweaking them manually until we find that the machine learning model has a decent enough accuracy rate and no overfitting that's satisfiable with us. It's not something that you could just kind of compute on your own.
And there's also, a further consideration with all this, that if you instrument, as we talked about, and find sort of that optimal split, like let's say splitting it into 8 chunks is the optimum. Well, that's the optimum on the machine you're testing. If you take that same code and run it on a processor that's, let's say you're working on just, you know, a basic M1 processor, and then you go and you run the code on a, you know, M4 Ultra Max Mega whatever, which can support, you know, 8 times as many threads, then you're not getting maximal efficiency on that processor. And the converse, if you do your testing and instrumentation on the, you know, M4 Ultra Gigamax, and then try to run the code on a basic M1, it'll be a lot less efficient because it's trying to do a whole bunch more threads than that processor is set up to handle. Yeah. So, which is why in some programs, like you know, you'll see this in like video editing programs and some high-end graphic 3D rendering programs, where in the settings you can go and set, okay, how many threads do you want to allocate in this program? Because that varies from machine to machine based on what the processor is actually able to do, as well as competing processes. Because if you have full ownership of the processor while you're running your code, then hey, laughing. But if, let's say, somebody's at the same time that they're running your code, which is trying to do parallel tasks, they're also running, you know, some local on machine learning stuff, which tends to be fairly processor intensive, you're going to get slowdowns. So you might not be at the optimum. So, you know, then you start to get into really advanced things like actually monitoring, you know, load usage and so on, and only spinning off additional tasks. And anyway, it gets far more advanced, and that's beyond what 99% of people need to care about in working with concurrency. And thankfully, as we're moving along here, the structured concurrency stuff that Swift is providing is taking care of a lot of that stuff for us. So it can become something like, okay, when I want to split up the tile that I'm rendering here into sub chunks, it's less about how many threads are optimal versus how much overhead is there per chunk, and trying to find that optimum point where, you know, there's some setup and some teardown for spinning off a task to do this chunk of the tile. So it becomes not really worth it if I'm only dealing with, say, 4 pixels, but if I'm dealing with, say, 32 pixels, maybe it is worth it. So you say, okay, what's my minimum chunk size? The chunk. Because if I'm only doing 4 pixels, that's probably not worth it in terms of the overhead for spinning off new tasks. Anyway, I'm throwing more than we needed to go into on this today, but yeah, I think the key takeaways are stick with Swift concurrency unless you're doing like really high performance video 3D rendering stuff, and use the instruments and profiler to figure out, okay, do I actually need to speed this up? Because unless you've done that, it's guesswork, and humans are terrible at guessing this stuff. Back to you, Marcus.
Yeah. Yeah, so we could just potentially just write our own Swift version and then try to do chunking on our own instead of just relying on the C call to do it.
That would be the step I would take here, because trying to mix in C threading with Swift code is,
yeah,
you know, we were already suffering. That's like the 9th circle of hell stuff.
Yeah, that's going to be pain and suffering. And also, not to mention, again, we still have the hard rule here where we cannot modify Cubiomes itself, because doing so would require a fork, and then I would have to try and maintain the changes as CubeTech makes changes to update for potentially new Minecraft versions and stuff, and that's just going to be a massive
And you just
headache.
want to be working on this stuff in Swift. Like
Yeah.
you don't even want to be working in the C stuff. You're just doing that. You're using it because it's there.
Yeah. So
Yeah.
I think a path forward here would be for us to rewrite biomes to image for our sake to do it.
Yeah.
I think.
And one of the things that would do as well is you then, some of these things that are in C types like that, biome IDs, you might be able to have that in a safe Swift format,
Yeah.
potentially, depending on where you're pulling it from and all this. But it might make things even simpler by Swiftifying it in some ways.
Yeah.
Potentially.
Yeah.
Maybe.
I think with this one, we would need to check because biome IDs.
Where's that coming from?
That comes from allocating cache.
So that is, yeah, you're calling into C to get that. So.
And I think this is just returning the pointer at which it starts.
Yeah. Yeah. So, okay. We don't get that without going and changing a bunch of other stuff too.
Yeah. Screw it. We're rewriting the entire library is now in Swift. I mean, that could be a fun exercise, rewriting the entire library, but that's not what we're here to do today.
Your definition of fun and my definition of fun are not quite in accord here, I think.
Like my high school physics teacher said, fun does not necessarily have to mean amusing. Put that in
fun in square quotes. Are we having fun yet?
But anyways, that's not what we're here to do today. So that's not.
I think that's kind of where we're at for today. We hit a bit of a dead end on that, but there's hope for the future.
Yeah.
So we didn't get to the parallelization of tasks that we wanted to look at today, but it was an interesting look at, some of these issues with the like edge types, like going from int32 to uint32 and identifying, okay, we've got this weird thing happening where it's giving us, can't convert negative. Why would it be doing that? And digging through, in that process of digging through the code to sort of figure out, okay, what is the source of this problem? So we did learn some stuff, not what we were hoping to learn, but we've laid some groundwork that we can come at that again in a subsequent session. Keith, any thoughts?
Well, I just wanted to thank you guys. It was fun and it was also amusing, or I don't know if they're the same or not. Thank you.
Yeah, for sure.
Of course. I think what we can do, and this may be something that we can discuss later, since we didn't get to everything fully with parallelization, I think we could kind of split this into like a part 1, part 2 type of thing.
Yeah, we'll have to at this point.
Yeah. Yeah, so let me just make sure we get this committed. Don't do the emoji until later. Lesson learned.
Yeah.
Now, Joe is not
Wrapped
here.
then emoji.
So... do that. Services. Format. Okay. Thank you. Okay. So we got that. I'll worry about pushing it up to the remote later. It's not a big deal.
Okay.
So yeah, I guess what we'll probably do then is we'll see if we can set up a part 2 for this where we, I guess, rewrite biomes to image and parallelize that.
Well, I would suggest 2 separate sessions. One for the Swiftifying the code, because that's a whole thing unto itself. And then once we've got that Swiftified code, then do the parallelization as a thing. Because I think there will be a number of people who who won't be interested in the Swiftifying C code, but will be interested in the concurrency side of it.
True. Though Swiftifying it is not strictly a concurrency related thing. That's the only thing I'm...
No, but that's a task that needs to be done, and it's an interesting thing in and of itself, but as a separate thing.
Right, yeah.
Single
Yeah.
responsibility principle.
Yeah, I mean, I agree with you. It's just like, we can't call it a concurrency learning session then because it's not related to concurrency.
It would just fall under our group learning sessions in general.
False advertising.
Yeah.
Yeah, so I think, so part 2 will be Swiftifying biomes to image. Part 3 will then be parallelizing it.
Right. That makes sense.
Yeah, you can do that. That works. Yeah, so cool beans. I think that is what we will do then. For those that are watching on YouTube, stay tuned for whenever we do that, because I'm probably going to be hosting those ones, so I'm going to be able to stream it again.
Cool.
In any
Thank
case,
you, Marcus.
in the event that that's not possible and it's only through Discord, I highly encourage you to join the Swift Dev Chat server. The links for that are in the description of the stream. Wherever YouTube puts descriptions nowadays, usually it's the bottom, but you never know. They sometimes do some weird things with UI. And stay tuned for when we put the event announcements there. Likewise, if you want to contribute along by throwing out suggestions or joining us in one of these sessions, that's the best way to do it, to join us in the server. With that then, I thank everyone for coming today, and until next time.